We've looked at using Pythagoras with 2D triangles. It can also be useful in 3D as well. But with 3D you have to take more than one step to find out what you want to know. Here's a cuboid. We want to know how far it is from one corner to the other, from A to D, i.e. across that red line there. We're given some information about the lengths of the sides and the height of that cube, but we need to find a diagonal distance. As soon as you're asked to find a diagonal distance, you should start thinking about Pythagoras. Okay, let's clear this and move the diagram up so we've got some space to work. Here we go, it's the same diagram. We want to find the distance AD. First of all, we're going to look at the distance AC. And we're going to do this by considering this triangle, the triangle ABC. Now at this point I would always advise you to draw out this new triangle so you can see exactly what's what. AC is the hypotenuse of that triangle, and we have the lengths of the other two sides. We know that one length is 3 and the other one is 7. So we have a right angled triangle. We know it's right angled because it's a cuboid, and we can use Pythagoras. So A to B squared plus B to C squared equals A to C squared. Put in the numbers that we have, the 7 and the 3, and we end up with 49 plus 9, which is 58. 58 is the length squared. So the length that we're wanting across the bottom there is 7.6 centimeters. Once you've worked it out, draw it on the diagram, because now we're going to make the second step, which is to actually work out what AD is. The trick to these kind of questions is recognizing that you have to do it in more than one step. So it's important that you write down everything you do. It's easy to make mistakes when you're writing down this much maths. So in this case we're going to use the triangle ACD. Can you see that triangle across the center there from one corner to the other? As before, we're going to draw that down to make sure that we don't get our numbers or our lengths in the wrong place. So there's our triangle ACD. We know that that length is 5, C to D, because it's on the diagram. We know the length A to C is 7.6 because we just worked it out. So again, we can use Pythagoras because this is a right angled triangle. Put the numbers into Pythagoras that we already have, 7.6 squared plus 5 squared, and we move swiftly along to the solution here, which ends up giving us an answer of A to D is equal to 9.1 centimeters. That question was really just two lots of Pythagoras, one after another. The kind of questions you might get with this is what's the longest broomstick you could put into a cupboard? You might be asked to find out what the height of this cuboid is given the diagonal distance. There's many different ways the question can be answered, but essentially you're doing the same thing, taking those two steps to work out either diagonals or straight edges using Pythagoras. You may well have spotted in there as well that we can generalize this solution to make it a little bit easier for us. So for any cuboid of length L, width W and height H, we don't have to always do it in two steps, because our diagonal distance from A to B, we're doing it this way round this time, the diagonal distance is the square root of L squared plus W squared plus H squared. And look back on the solution to the previous bit where we did it in two steps to see exactly why this is. If you get yourself a pencil and paper out and write those down, you will see why we can generalize the solution in this way. Let's do this with an example just quickly. Here's a cuboid, length, height and width. So the diagonal distance from A to B is 5 squared plus 3 squared plus 4 squared, all square rooted. So that distance is the square root of 50, which just happens to be 7.1 centimeters. There's always quite a lot going on in these kind of questions. Make sure you write down everything you do carefully, and do make sure you go back and check what you've done as you do it. Also, ask yourself, does the solution make sense? If you think of the size of that box, well, how big a pencil, for example, could you put in a box that size from corner to corner? It's going to be more than 5 centimetres, but it's probably going to be a lot less than 10. So our answer does make some sort of sense. Always do that kind of reality check for any question that you try and answer.